let's come up with some or derive some log rules. So the first rule or first log rule we have is if I have a log base b, so it could be any base under the sun. And who remembers if there's no base written down, what base is it? 10. Good. So if I have log base b of x times y, so inside the argument, I'm multiplying two things within the argument. This is going to be the same as log base b of x plus log base b of y. And I'm going to be, and there's obviously restrictions. The restrictions are going to be x has to be greater than 0, y has to be greater than 0, and we know any base we have has to be greater than 0 because really the base is the base of an exponential where the exponent is unknown. So we can't have a base less than 1. And I'm also going to say b cannot equal 1. And I'm going to show you why this holds true. So an example would be, let's say I have log base 2 of 8 times 32. Now remember, any log can get changed into an exponential, right? Do I need an equal sign for a log and something after it? No, we don't need that. So if I'm going to change this into an exponential, do we all agree this is going to be 2 to the x power is equal to the argument, which is 8 times 32? We're all in agreement of this? Okay, so now do we also agree this is the same if I'm trying to create the same base? This is 2 to the x power, like we were doing yesterday, is equal to 2 to the third power times 2 to the fifth power. Not really changing anything, right? So now the rule with exponents says if my base is the same and I'm multiplying, keep your base and do what with your exponents? Add them. So this would be 3 plus 5. So do we agree x would equal 3 plus 5, which is 8? Right. So now what the rule said, the rule I told you, is if I log base and then there's two things being multiplied in my argument, it's the same as taking the arguments and adding them the log of each argument. What does that mean? This means this is going to be the equivalent to log base 2 of 8 plus log base 2 of 32. These are interchangeable. So if I have a log where the arguments are being multiplied, I can turn them into the addition of each log of that argument. Or if I have the log addition, I could turn it back to multiplication. So we can go both ways here. And now we can almost do this in our head. Isn't log base 2 of 8 saying 2 to what power gives us 8? Right? So what's log base 2 of 8? 3. And then log base 2 of 32 is saying 2 to what power gives me 32? Can't we do that in our head? 2 to what power gives us 32? 5. What's 3 plus 8? 3 plus 5? 8. Didn't we get the same answer both times? Okay, so that's the first rule, saying if my argument's being multiplied, I could expand it into log addition. And the next rule, so this was our first rule. Do you think we should memorize this rule? Absolutely. All right, the second rule, purple, tells us if I have log base b and now I'm dividing inside the argument. So x divided by y. This is the same as log base b of x minus log base b of y. And the same restrictions that we've been having still occur. X has to be greater than 0, y has to be greater than 0, and b cannot equal 1. And I'm going to give you an example here. But this is the formula we sort of need to memorize, or the rule, not really a formula, the rule we need to know. Okay, let's see how this works. So let's say I have log base 2 of 128 over 8. Do we agree? This is the same as saying, if I'm changing it back into exponential, 2 to the x equals 128 over 8. Now, if I'm trying to create a base of 2, this is saying 2 to the x is equal to, and I don't know if you guys know this off the top of your head real quick, but I will tell you, 128 is the same as 2 to the 7th power, and 8 we all know is 2 to the 3rd power. And now, when we're dividing with the same base, we keep our base and do what with the exponents? When we're dividing exponential expressions, subtract them. So this is 2 raised to the 7 minus 3 power. So do we agree? Since our base is the same, I can now say x is equal to 7 minus 3, which is 4. Okay. Sure. Yeah. All right. And now, so I'm saying that, again, it goes both ways here. I could turn the division of an argument into log subtraction. So I could say this is the same as log base 2 of 128 minus log base 2 of 8. And so again, we can figure this out. Log base 2 of 128 says 2 to what power gives me 128? Didn't we just figure that out? 2 to what power gives us 128? 7. And then log base 2 of 8 says 2 to what power gives me 8? Isn't it 3? And what's 7 minus 3? 4. So we see how it's the same both ways? Okay, great. So now what we're going to do is we're going to practice going from expanded form and then writing as one single expression. So let's go through sample problems. Let's go blue here. For the first problem, I want us to write log base 3 of 5c over pi d in expanded form. Now, to expand something, doesn't it mean to stretch it, to make it bigger, right? So if I'm taking this and I'm expanding it, obviously we're making it longer, we're making it bigger. So for me to make this longer, make it bigger, I see within my argument, the first thing I'm noticing is division. So within my argument, I see that fraction bar that represents division, which means I can change my argument that's being divided into log what? Subtraction. So we can change that argument that's being divided into log subtraction. So what is this going to be? It's going to be log base 3 of 5c minus log base 3 of pi d. Are we okay so far? I'm not done though. Why am I not done? There's even more going on here. What operations between the 5 and the c? Isn't that multiplication? And what operations between the pi and the d? Isn't that also multiplication? So when I say write in expanded form, I want it as long as possible. We cannot leave any division. We cannot leave any multiplication within that argument. So now what am I going to do? I'm going to change that argument that's being multiplied into log what? Addition. So this is going to be log base 3 of 5 plus log base 3 of c. Minus, but now because I'm now changing that log after the minus sign into a binomial, what do you think I have to put? Parentheses. So we're going to open our parentheses and we're going to say log base 3 of pi plus log base 3 of d. And then what do you think I'm going to tell you to do with that minus? Distribute it in. In all fairness, though, if this was a test question and you were to leave it like this, I would give you full credit. You showed me you knew what you were doing. If you wanted to take it, so if you wanted to leave it like this, I'd give it to you. If you took it a step further, great. So this is expanded form. Expanded form is when we make it as long as possible. We're not leaving any multiplication in the argument. We're not leaving any division in that argument. We do not leave any multiplication or division within the argument. That's expanded form. We expand it, we make it bigger, we make it longer. So now this next problem I'm going to say, write log base 3 of 7 plus log base 3 of x minus log base 3 of 4 minus log base 3 of v as one expression. So now I'm condensing this. So I gave you it really long. Now I need to make it into one expression. So the first thing I notice is I'm going to group these two together. Why am I going to group those two together? Log base 3 of 7 plus log base 3 of x. Because log addition, Violet? Good. Log addition means I can simplify that into multiplication of the arguments. So now I'm going to basically pull out a log base 3, and then I'm going to have 7 times x, which is 7x. Are we all okay with that? Now, I see a minus and another minus. Because I see a negative and then another negative, in my brain, I'm like, that negative had definitely been distributed in. That negative had definitely been distributed in. So since I recognize that that negative had been distributed in, guess what I'm going to do? Pull out a negative. So I'm going to group these together, and I'm going to pull out a negative. And when I pull out that negative, I'm going to have log base 3 of 4 plus log base 3 of v. Is everybody okay with this so far? Anybody confused with how I got this minus right here? Okay, so now I'm going to work on the other side of that minus sign. So we're log base 3 of 7x minus log base 3 of 4v. Am I finished? No, because what I see right now is I see a log base 3 of some argument minus the same log and base of another argument. And we learned that log subtraction can be condensed to division. So now this is going to be log base 3 of 7x minus divided by 4v. Is this now as condensed as possible? Yeah, there's no addition, there's no subtraction. We are only multiplication and division into one log argument. All right, you guys try this one. So you're doing those two problems. Who needs another minute? Ready? Okay, can somebody tell me what you get for this expanded form? Charlie?
Log BC, and then minus log B3, and then minus log BD.
Sorry, I needed a little bit more space here. Do it again, but it was perfect. So what Charlie said was we were log base B of 5 plus log base B of C minus log base B of 3 minus log base B of D. If you were to have written log base B of 5 plus log base B of C minus parentheses log base B of 3 plus log base b of d. Would I have accepted that also? Yes. Anybody need to see me do this? All right, who thinks they got number 4? This one was a little bit trickier. Devarshi? Absolutely perfect. Anybody need to see me do that one? No? We're good? See it? Sure. Okay. So do you see how on the left side it's subtraction, but then there's addition, and on the right side there's subtraction? Because there's addition between them, I can't group together and pull out a negative. Does that make sense? All right. So I'm going to treat them separately on the left of the right side first, and then to the right of the addition side. So left of addition sign, right of addition sign. So to the left of the addition sign, I have log subtraction, which we can condense into the division of the arguments. You good with that? And then on the right side, again, I have subtraction, which I can condense to the division of the arguments. So now I have log base 4 of an argument plus log base 4 of another argument. Because it's the same log with the same base and there's addition between them, I can now condense that into multiplication of their arguments. And when you multiply, you just multiply across. So 7 times 3 is 21. M times N is MN.
I have a question. Could you just group the positives together and negatives together? That's what I meant.
Yeah, addition is commutative, right? So you can absolutely do that. All right, next one. Okay, so now let's talk about powers, log powers. Oops, log of powers, logs of powers, sorry, logs of powers. So the rule is telling us if I have log base b of x raised to some exponent, we are allowed to pull that exponent in front, and that's going to be that exponent times log base b of x. So this is our next rule. And I'll show you why this works. So an example of this would be, let's say I have log base 2 of 5 to the 3rd power. Do we agree this means log base 2 of 5 times 5 times 5? Okay, and now because there's multiplication in my argument, isn't this the same as log base 2 of 5 plus log base 2 of 5 if I were to expand it, plus log base 2 of 5? And isn't log base 2 of 5 plus log base 2 of 5 plus log base 2 of 5 the same as saying 3 times log base 2 of 5? And isn't that exactly what the rule tells us? That if I have a log and my argument is raised to an exponent, that I can pull that exponent in the front and just multiply it by the log expression. And that goes both ways. I could take that multiplication, put it back as an exponent if I wanted to, or take the exponent and put it in the front as multiplication. And now I just want to recap radicals, something about radicals real quick. Remember, if I have the nth root of x to the second power, how would I change that into exponential? So if I have the nth root of x2, sorry, let's not have the second power. Let's have a variable power to the m power. Charlie? Good. X to the power of m over n. What if I didn't have an exponent on the inside? So if I had the nth root of just x, what would that be? Ariana? You got it. X to the power of 1 over n. Okay. So let's do some problems. So log base 5 of m n to the third power, that whole quantity raised to the second power. I want to expand this. I want to make this as long as possible. So I'm actually going to work from my outside this time. Do you see how I have this power of 2 raised to the whole entire argument? Because that power of 2 is raised to the whole argument, sorry, is raised to that power of 2. I worded that wrong. That whole argument is raised to the power of 2. This 2 I can pull in the front. And so this becomes 2 times the log base 5 of mn to the third. I pulled that 3 in the front also. Can I pull that 3 in the front and make this a 6? Good. Why no? Why can't I? Not the m, just the n. So this 3 only belongs, this exponent of 3 only belongs to the n. It does not belong to the m. It does not belong to the whole argument, just the n. So now I'm going to sort of work with inside these parentheses. Do we agree it's multiplication between the m and the n? Yes? Okay. But now this 2 is being multiplied with everything. And now I'm expanding this monomial into something bigger than a monomial. And that 2 needs to be multiplied with all of it. So what do you think I have to put? Parentheses. So we're going to have log base 5 of m plus log base 5 of n cubed. Actually need these parentheses there. There's nothing else there. And this is almost perfect. Anybody have any ideas why this is almost perfect but not quite there? Mariana? Yep. Isn't this argument being cubed? So now I can pull that 3 to the front. Could I pull it in the front with the 2? No, I can't put it to the front of the 2, but I can put it in front just of that second log, right? So this is going to be 2 times log base 5 of m plus 2 times the log base 5 of n. I can leave it like this, or what else can we do? If we wanted to, what else could we do?
Why is it 2?
Oh, that's not a 2. That's a 3. Sorry. I wrote it wrong. That's a 3. Thanks for that catch. So I can leave it like this. What else can I do? Anybody know? Amanda? Yeah, you could absolutely distribute in that too. I'm going to choose to leave it like this, but if you wanted to distribute it in, we absolutely could. Okay, I have a radical. I have the fourth root of m cubed over n. What do you think I'm going to recommend we do with that radical? Change it to what? What do you think we're going to recommend I do to that radical? Good. We're going to change it to an exponent. So we're log base b of m to the third over n raised to what power? Ariana? The 1/4 power. So now I have an argument raised to an exponent. What can I do with that 1/4? Bring it to the front. So now this is going to be 1/4 times log base b of m to the third over n. Now, do we agree within that argument we see division? So I can change that division into what? Log subtraction. But because this 1/4 has to be multiplied by that whole expression, do I need parentheses? Absolutely. So I'm going to open my brackets. I'm going to have log base b of m to the third minus log base b of n. Am I finished here? No, I now have another exponent. Now I could bring that 3. Could I bring the 3 into the front of the brackets? No, I can bring that 3 just to the front of the first log. So this ends up being 1/4 times the quantity of 3 times the log base b of m minus log base b of n. Could I distribute in that 1/4 if I wanted to? Absolutely. Do I have to? No. Okay. The next thing I'm going to do is more rules. They're shortcuts. Now, these are shortcut rules. I'm going to write them all out, and then I'll explain each one to you. The first shortcut rule says if I have log base b of b, that's going to equal 1. Second rule, if I have the ln of e, that equals 1. Third rule, if I have log base b of b to the t power, that equals t. Like I said, I'm going to write down out all my shortcuts, and then I'll explain each one. There's one more. If I have b raised to the log base b of t, that's going to equal t. The first two shortcuts are essentially the same thing, I'll explain to you why in a minute. Do you think we need to memorize these shortcuts? Absolutely. All right, are we ready for the explanation of why each of these holds true? All right, so for the first one, log base b of b. So when I have log base b of b, do we agree this is saying b to what power equals b? B to what power gives us b to the first? 1. Does that make sense? And for the second one, it says ln of e is 1. Well, we have to remember, what does the ln stand for? What does it represent? Ariana? Log base e. So this is saying log base e of e equals 1. Well, isn't log base b of b equals 1 when my base and my argument are the same? It's 1. Same thing. My base and my argument are the same. So what does it equal? 1. So this is saying e to what power equals e to the first? 1, right? Now this last one is saying log base b of b to the t equals t. So they're saying b to what power gives me b to the t? So b to what power gives me b to the t? So what is this saying? If my base and the base of my argument are the same, it's going to simplify down to the exponent on that argument. So b to the x equals b to the t. What does that mean? X has to equal t. So essentially, the first three are saying the same exact thing. When my base and my base of my argument are the same, when the base of my log and the base of my argument are the same, it simplifies down to just the exponent on the argument. That's what basically all three of these are saying. When the base of my log and the base of my argument are the same, it ends up being just the exponent on the argument. Anybody confused so far? We're okay? Okay, so now the last one. The last one's a little bit trickier. So this is saying, let's say I have log b raised to the log base b of t equals x. Do we all agree this is our exponent? And so I'm going to change this into a log. So if this is my exponent, it's log base exponent. Oh, sorry, no, not exponent, answer equals exponent. So this ends up becoming log base b of x equals log base b of t. Is everybody good with how I went from this expression to this one? I just changed it into a log. Base exponent answer. Base exponent answer, log base answer equals exponent. And now because I have log base b, so I have the same log on either side with the same base, don't their arguments have to be equal? So this ends up showing that x has to equal t. All right, so what's the takeaway from this short? If I have some base raised to an exponent that's a log with the same base as the base of my exponential expression. So if the base of my exponential expression is raised to the log with the same base, it's going to end up simplifying down to the argument. That's what this is saying. It's going to end up simplifying down, to the argument of our exponent. All right, are we ready to do some problems? All right. Okay, so what do I want you to notice? I have a base of 4 raised to a log with the same base as the base of my exponential. So is this a shortcut? Absolutely. This fits the shortcut that says b raised to the log base b of t. And what does b raised to the log base b of t equal? T. So what does that mean? This has to end up being the argument, which is 7. That's what that simplifies down to. Next one is log base A of log base A of A. I'm going to work within my parentheses first. So I have log base A of A. What does this tell me? I have a log with a base that's the same as the argument. That was a shortcut. Log base A of A was the same as this first shortcut, log base B of B. And what does that simplify down to? 1, right? Log base A of A. So they're saying A to what power gives me A? Isn't it A to the first power gives me A? So this is 1. Is everybody okay with that? So now I have log base A of 1. Well, what is this saying? Log base A of 1. Log base A of 1. What is this asking? Lily? Excellent. This is now saying A to what power gives us 1? Well, what power always gives us 1? 0. So isn't log base A of 1 0? All right, last thing I need to show you. Actually, is there anything else I need to show you for these? Oh, hold on. There's one more of these. 2 more of these, and then one more thing I need to show you. I know we're going till the end, guys. It was a very long lesson. I'm sorry. Tomorrow's lesson won't be as long. Oops, sorry. That was wrong. I see a lot going on in that exponent. Do you agree? Do any of the logs in the exponent actually have a base written down? No, that's okay because there's no base written down. It's implied it's a base of 10. Do they have the same base? Yes, because they have the same base, can I condense this exponent down into one exponential expression? Absolutely. The first thing I'm going to do is take that 2 and put it back as an exponent. I'm going to take this 2 and put it back as an exponent. Are we okay with that so far? So this becomes 10 raised to the log base 10 of 3 squared plus log base 10 of 4 squared. Am I able to square 3 and 4? Yeah. So this is going to be 10 raised to the log base 10 of 9 plus the log base 10 of 16. Now I can change that log addition into what? Multiplication. So this is going to be 10 raised to the log of 9 times 16. What's 9 times 16? 144. Is this a shortcut? It may not look like a shortcut, but now if I were to put a 10 there, is this a shortcut? Yeah. I have my exponential base of 10 raised to a log with the same base. Remember that? when you have a base raised to the log with the same base of an argument in that exponent. So this was the shortcut, b raised to the log base b of t. And who remembers what does that equal? T. So what is this? 10 raised to the log of 144? 144. So I'm looking at this. I first even noticed they don't even have the same base. I have log base 4 of log base 3 of 81. So now I'm going to work inside my parentheses. And I'm going to ask myself, can I simplify within these parentheses? I think I can. So I'm going to have log base 4, and then I'm going to see. I have log base 3. Is there any way to change 81 into a base of 3? Yeah, we can change 81 into 3 to what power? The fourth power. And then I look here. Is this a shortcut? Log base 3 of 3 to the fourth? Yeah, log base b of b to the t is just t. So what does this simplify down to? 4. So now I have log base 4 of 4. What's log base 4 of 4? 1. All right. Very last thing I need to show you. Let's say, so number 5. Let's say I have log base b of 2 equals r. Log base b of 3 is equal to t. And log base b of 5 is equal to w. And I want to write in terms of r, t, and w. Log base b of 15. Or sorry, log base b of 30. Okay, so I need to make 30 into some multiple of 2, 3, and 5. So do we agree if I have log base b, I can change 30 into 2 times 3 times 5? All right, I haven't changed anything, right? 30 is the same as 2 times 3 times 5. I haven't changed anything. But now, because it's a multiplication between the argument, can I turn that into addition? So this is log base b of 2 plus log base b of 3 plus log base b of 5. And what did I say in the given information log base b of 2 was the same as? R. So this is R. What did I say log base b of 3 was? T. So it's R plus T plus what's log base b of 5? W. So did I write this expression in terms of R, T, and W? Yes. Okay, so